Hello everyone, welcome back to the channel. Today we are building something amazing, a complete DevOps pipeline from scratch. In this video, we are going to take a simple Python Flask API and take it all the way from local development to Docker, Kubernetes and Helm, all automated with GitHub Actions and Argo CD. And the best part, this is a beginner-friendly project. By the end, you will understand how real-world DevOps automation works from code commit to production deployment. Let us take a look at our tech stack. We're going to use Python Flask to build our actual application because it's lightweight and perfect for API. Then we will have Docker to package our app so it runs exactly the same on our machine as it does on the server. Kubernetes is the captain of the ship, which manages our containers and makes sure they stay running. And we will use Traefik, which is our gateway. It acts like a receptionist, taking incoming internet traffic and routing it to the right place. Helm, think of this as the app store for Kubernetes. It helps us manage complex Kubernetes configuration using simple templates. And we will use Argo CD, which is the heart of our GitOps. It watches our GitHub repo. The moment we change code, Argo CD automatically syncs those changes to our cluster. And last but not the least, we will use GitHub Actions, which is our automation engine. It handles the heavy lifting of building images and pushing them to the DockerHub. Before we code, we need to decide where we're going to store our application code, Kubernetes manifest, Helm charts, etc. securely and reliably. And the answer is GitHub. GitHub is used by developers and teams to store and manage code collaboratively, keeping track of every changes through version control with Git. It also enables automation, reviews, and deployment workflows, making teams and DevOps integration seamless. If you already have a GitHub account, you can click on Sign In. If not, please go ahead and sign up for a free account. I'll click on Sign In. Use my email address to log in. I have logged into my GitHub account. We are going to create two repositories, one for application code, where we'll have our Python source code, Dockerfile, etc. And we have another separate repository, which is for our infrastructure, where we're going to store our Helm charts, the Kubernetes manifest, and Argo CD config. Let us head back to GitHub. On the left-hand side, let us click on New to create a repository. And we're going to call our repository Python app. And we can add the same for the description. And I will leave the visibility to public and click on Create Repository. So we have successfully created our first repository. Let us go ahead and clone this repository to our local. Ensure you selected HTTPS and click on the copy. Once done, let's head back to our terminal. In my case, I'm on a Linux-based operating system, which is Ubuntu. If you're on a Mac, you can follow the same instructions. If you are on a Windows, you can install WSL and configure Ubuntu. Once done, you should execute the same commands and follow the guide. I will create a new directory. I will call it project. Let's navigate to the project directory. And we're inside the project directory now. To clone our GitHub repo, we need Git. And currently, Git is not installed on my system. So if I run git version, it says the command not found. We can simply run sudo apt install git on Ubuntu to install Git. So let me hit enter. And it is prompting me to enter the password. I will type my password. It's installing Git on our machine. Once done, if we run the git version command again, and we should be able to get a response stating it is running the version 2.48.1. Once done, we're going to use the git clone command to clone the repository which we created a minute ago. I will run git clone and the URL, which is https://github.com, then my username and the repository name, which is python-app.git. Let's hit enter. So it says that you're cloning the repo, and it also warns us that we're cloning an empty repository. That is fine because we currently don't have anything in the repo. Let us start building our Python application using Flask. The first thing we need is a code editor. In my case, I will use Visual Studio Code. You can download it by visiting code.visualstudio.com, and based on your operating system, you can choose and install it. There are two ways you can launch the VS Code. The first and the easiest option is in the project directory, you can run code space dot. This would launch the VS Code. Or you can click on File and you can click on Open Folder and navigate to the directory. By convention, a source directory is used to store all the application code. Let us follow the same. Select the Python app and click on New Folder and create a directory called source, or src in short. And inside the src directory, we are going to create a new file and we will name it app.py. This is our application code where we are importing the Flask and JSONify. Flask is the engine that handles our web request, and JSONify is a helper that converts our Python data into a JSON format. Our next line, we are importing the datetime and the socket module. These are used to fetch the current time and the name of the host where the code is running on. Line number 4, we are initializing the application and we are creating two endpoints. One /API/v1/info, which basically prints the time and the host name. And we have another endpoint called API/v1/health, which show you a status up and a status code 200. We will use this endpoint to define our liveness and readiness probe when we start creating our Kubernetes manifest and Helm charts. And finally, we are defining app.run is equal to host, which is 0.0.0.0, and the port number is 5000. This basically tells the app to listen for connections from any network interface, not just the internal. This is very critical for Docker and Kubernetes, so ensure that you have this line defined. We need Flask to run this Python application. We will define a requirements.txt file and specify the Flask version, which we will install while running this Python application. Head back to python-app, click on New File and create a requirements.txt. Let us define the Flask version, which is 3.0.3, and save. So we have our requirements.txt file and our app.py. Let us go ahead and run this locally to test if our application is working as expected. I will open a terminal by clicking on Terminal and New Terminal. Let me maximize the pane. And the first thing is we need to ensure a Python is installed on our machine. By default, all the modern day operating systems comes with Python 3 installed. So you can verify by running Python 3 -- version command. In my case, I have a Python version 3.13.3 installed. Let us navigate into our python-app directory using cd, then the name of the directory, python-app. And we have requirement.txt and src folder. Let us go ahead and create a Python virtual environment to test our application safely. We'll do that by running python 3-m, then venv, followed by the name of our environment, which is API. Let's hit enter. This creates a directory called API, which we can see on the left-hand side. Let us go ahead and activate our virtual environment by using the source command. I will run source, then the name of our environment, which is API/bin/activate. And on the right hand side, we can see our virtual environment is activated. Let us use the pip3 command to install our Flask using pip3 install space -r, then the requirements.txt. Let's hit enter. This installs the Flask version 3.0.3. Let's navigate into the source directory and we have our app.py. Let us run using the Python 3 command, Python 3 app.py. And we can see it says this is a development server, do not use it for production. That is fine. And we can access it by hitting the localhost :5000. Let us head back to our browser, open a new tab and type http://localhost port 5000. Let's hit enter. Why are we not able to access our application? So let us go back to our VS Code. And if we take a look, we need to access it using our endpoints, which is like /API /v1info r /API /v1 r health. Let's try this. I will copy the endpoint. Let's head back and update our URL by adding the /API /v1/info and hit enter. So we are able to see the JSON output, which shows the hostname, which is mkbn, and this is the date and time. We can also access our health. Just replace the info by health. We'll type HEALTHZ and hit enter, and it shows status is up. Great, our API is working locally, but there is a problem. This only works on my machine with my specific Python version and dependencies. That's where Docker comes in. Docker allows us to bundle the code, dependencies, and runtime environment into a single image, so it runs anywhere, whether on your laptop or cloud. Let us go ahead and install Docker on our machine. Let us open a new tab and search install Docker. There are many ways you can install Docker. One of the ways is to install the Docker desktop, but we will install Docker directly on our Ubuntu. I will choose Ubuntu. We will use a simple installation script, which would allow you to deploy Docker on your machine. Let us copy the curl command. Let's head back to our terminal. I will open a new tab and paste. This downloaded the get-docker.sh command. We can simply run sudo sh, then the get-docker.sh, then hit enter. It's prompting me to enter the password. I will enter the password, and this is executing the Docker install script. All right, the Docker is successfully installed. We can verify by running sudo docker version command. In my case, it has installed 29.1.3. If we try to run the Docker commands without prefixing sudo, it says permission denied. Let's go ahead and fix it. Let's head back to the Docker website, scroll down, and click on post installation steps for Linux. And we need to create a group called Docker. Let us run sudo group add the Docker command, which says the group Docker already exists. Next, we need to add our user to the Docker group. We will run sudo user mod -ag space the group name, which is Docker, followed by $user. Let's hit enter. Once done, we need to log out and log back in, or we can run the new group space the Docker command. And now we should be able to run our Docker commands without prefixing sudo. Let us try. I will run docker space ps, and it works fine. Now we will write a simple Docker file, build the image using Docker build, and test it with Docker run. Let's head back to our VS Code. Let me cancel this by hitting Ctrl+C and clear the screen. Let me close the terminal. Click on Python-app directory and create a new file called Dockerfile. The first instruction which we're going to write is called from. This will tell our Docker to which base image to use while building our Python application. We will use Python 3.13.3 since we use the same while testing it locally. Let's copy the requirement.txt file using the copy instruction, and we will copy it to /temp. We installed the dependencies specified in the requirement.txt using the pip command. We can do the same by using the run instruction. We'll say run pip install -r /tmp, then the name of the file requirements.txt. We will copy our source directory, which has app.py, to a directory called source to avoid confusion. We can do that using the copy command, then say /src, then copy to src, our source. We will expose our port 5000 using the expose instruction, and finally execute our application.py using the Python command. We can do the same using the cmd instruction in Docker and specifying the command, which is Python followed by /src/app.py. Let us build the image using Docker build and test it with Docker run. Let us navigate into our source directory, which is Python app, where we have our Docker file, and let us run docker build -t, which is tag. I will call my image Python app :tag v1, then dot, to tell the Docker file exists in the current directory. It downloads the base image, copies the requirement.txt to /temp, runs pip install command to install the dependency, then copies the source directory and execute the Python /src/app.py. If we run docker images, we see a new image is built, which is Python app :v1. Let us create a Docker container using the image which we built to test if our application is working as expected. We can do that by using the docker run command followed by --name. I will call my Docker container Python app followed by the port 5000, then the image Python -app :v1. Let's hit enter. We can access our application using the localhost :5000 or using the IP, which is 172.17.0.2. Let's head back to our browser, open a new tab, and we will use the IP. Okay, it says not found because we need to pass /API/v1/info. So we are able to access our application. And if you see the host name, which is 4E36, this is the container ID. If we head back, we need to cancel this and do docker ps-a. And if you can see, this is 4E360, ends with 6E8. So that is the host name. Perfect. The app runs smoothly in a container, meaning we can now ship it anywhere reliably. Now let us push our container image to DockerHub. Let's head back to our browser, and in a new tab, we will search DockerHub and open the first link, which is hub.docker.com. DockerHub is a public container registry like GitHub, but for container images. When we built our Docker image, we used Python 3.13 image. That was a public image. We can click on Python, and you see we have the Python public image, and we can also verify the tags, and the 3.13 slim is available. Hence, we were able to successfully build our image using Python 3.13 base image. If you already have an account, you can click on sign in. If not, go ahead and sign up for a free DockerHub account. I have an account. Let me quickly sign in. I have logged into my DockerHub account. This is how it looks. you have your repository, your hardened images, and other settings. In order to push our image to DockerHub, we need to first log in to our account using docker login command. Let us click on our username, go to account settings, and click on personal access token. Let us create a personal access token by clicking on generate new token. I will call Python app token, and expiration I will set it for 30 days, and we're going to give the access permission read, write, and delete. So let's click on generate. Now we have our login command with our personal access token. Ensure that you save the personal access token, because once you close this, you will not be able to get it back. Let's copy the docker login command, head back to our browser and run docker login -u. My username is mkbn, and hit enter. So it is prompting for the password. Let's copy the personal access token and paste. So the login is succeeded. And now we will be able to push our local images to DockerHub. Let's do that. The first thing, let us check our image by running docker images command. So we currently have a single image called python-app:\v1. So in order to push an image to DockerHub, we need to tag our image with our username, followed by the name of the image, followed by the tag. So let's do that using the docker tag command. So let us use docker image tag, and we're going to copy the name of our existing image, which is python-app:\v1, and we are going to tag it mkbn, which is my username, followed by the image name. I will call this python-app:\v1. Let's hit enter. And if we rerun the docker images command, we see that we currently have two images, one with my username and the other one is a python-app:\v1. Let us go ahead and push the image to DockerHub. We can simply do that by using docker push, then the username / image name : the tag, and hit enter. So it is pushing the image to DockerHub. The image is successfully pushed to our DockerHub. Let's head back. I will just copy this and save it somewhere safe, and we can go back to our repository hub, then repository, and we see we have a new image which is published less than a minute ago, and this is the name of the image, mkbn/python-app, and this is how you can pull the image. Let me show you how to pull the image also. So we currently have the image. Let's go ahead and remove it by using docker rmi command, which is remove image followed by the image name. So it is untagged, and if we see the images we currently don't have, so what we can do is we can use the docker pull command to pull the image, and this is the command to push it, and we can pull by running docker pull the image name mkbn/python-app:\v1 and hit enter. So it is pulling the image from mkbn/python-app, and we can run docker images and we should have the image. Before we proceed further, let us go ahead and push all our changes to our GitHub repo. Let us run git status, and we currently have the Docker file, the requirement.txt, and the source file. So we can go ahead and do git add dot and run the git status command again, and we can commit our changes by using git commit -am, I would say initial commit, and the following three files will be pushed to a remote repository, and we can say git push origin main. Our changes are pushed to our git repository. Let's head back to our browser and go to our GitHub Python app. And if we refresh, we should have our changes pushed to our remote repository. So we have our Dockerfile, the requirement.txt, and the source directory, which has our app.py. Now that our application image is ready and pushed to DockerHub, let's move to Kubernetes, the container orchestration engine. We are going to use Kind to build our Kubernetes cluster. Let us go to Kind website and click on installation. Since we are on Linux, we can copy the following command and install Kind. Let me enter the password. We can verify if the Kind is installed by running kind space version command. And in our case, it is installed successfully. Let us create a kind-config.yaml file, which will be used to build our Kubernetes cluster. Since kind runs in Docker, we must map our port 80 from our host to the kind node container. Hence, I have defined the host port as 80 and the protocol is TCP. Let's save and exit. Let us create the cluster using the kind create cluster command. I will run kind create cluster followed by the config --config, then the config file, which is kind-config.yaml. It is creating a kind cluster and the Kubernetes version is 1.35.0. And our cluster is installed successfully. In order to access the cluster, you need the kubectl tool installed and configured. In my case, I have already installed kubectl. And if you don't have kubectl installed on your machine, you can head back to your browser, open a new tab and search install kubectl and hit enter. We can open the first link, which is the official Kubernetes documentation site, which helps us to install the kubectl. You can choose the version, which is 1.35 in our case. And based on the architecture, x86 or ARM, you can just copy the command and scroll down. You can just install the kubectl using the following command. Once done, we will set our cluster context to kind by copying the following command and run. And once done, we should be able to run kubectl get nodes. And we see we have a kind control plane, which is ready and version 1.35.0 is running. Let's head back to our GitHub repo and create a new repository to host our infrastructure resources like Kubernetes manifest, Helm charts, etc. I'll click on repositories and create a new repository, and I will call this infra-repo. And we will keep the visibility to public and click on create repository. Let's choose HTTPS and copy. Head back to our terminal, and in the project directory, let us go ahead and clone the infra-repo using git clone followed by the URL, and we have successfully cloned the repo. Let's open the VS Code. Let me close the terminal, the Dockerfile, and we currently have two directories. One is Python app, the other one is Infra-repo, which is currently empty. Inside the Infra-repo, let us create a directory called KTS manifest. Enter. And this is what we are going to do. We will create a deployment and service YAML file inside the KTS manifest directory. Then we will apply this manifest using kubectl. Let me create two files, one called deployment.yaml and the other one is service.yaml. So let us go ahead and create the deployment.yaml. If we head back to our official Kubernetes documentation, we can click on documentation and search deployment. and the Kubernetes deployment. Let's open that. If we scroll down, we have a deployment sample. We can quickly copy this, head back and paste. So we are going to modify the following deployment file so that we can use it to deploy our Python application. So I will rename the name to Python app, and the label I would keep the same. Let me copy Python app, select the text, do a Control F, then replace everything with Python app. And we're going to run a single replica. That should be enough for testing. Then we need to change our image, which is mkbn/python-app:v1. If we go back to our DockerHub, and we know that our image name is mkbn/python-app and the tag is v1. And when it comes to the container port, we're using 5000. If we head back to our Python app and in the source, if we check the app.py, our application is using a port number 5000. Hence, we're going to define our container port as 5000. So that's all we need to do. And let's head back to our Kubernetes documentation and look for service. And let us open the service. And if we scroll down, we have a manifest. We can quickly copy and paste it here. And we just need to change the name of the service. I will Python app-service. We can call anything. Then we don't need, we just need to change the selector, which is Python-app. Then the protocol TCP, the port is, we're going to set it to 8080, and the target port, which is our container, which is our application port 5000. And let's save this. So we currently have created a deployment.yaml and a service.yaml file. Let's go ahead and try to apply this into our Kubernetes cluster. Let me head back to our terminal. Let's navigate to the Infra-repo. And in the KTS manifest, we have the deployment.yaml and the service.yaml. Let's run kubectl create -f, then deployment.yaml, hit enter. And we can run kubectl get pods, then keep a watch. So look like we have some issue with the image. Let's quickly check. kubectl describe pod, then we're going to paste the pod name. So let's head back, and if we check our DockerHub, let's go to the repositories, and currently our repository is private, hence it is unable to pull the image. Let's quickly go ahead and change it to public. Let's click on settings, and we will make it public. Type Python app to continue. Click on make public. Once done, let's head back. Let's do a rollout restart. kubectl rollout restart, deploy, then Python app. So it's restarted. Let's rerun the kubectl get pods command again, and it is container creating, and our container is running now. Let's go ahead and apply our service manifest file. I will run kubectl create -f service.yaml, and we can run kubectl get svc, and we have a new service called Python-app-service. We can run kubectl get pods -o-wide, which shows our pod IP, and we can verify our service is attached to our deployment by running kubectl get ep, stand for endpoints, and we have our pod IP, which is 10.244.0.6, followed by our container port 5000. Since the service type is cluster IP, we can use the port forward to access our application. Let's run kubectl port forward followed by the service name python-app-service. Then I will map the host port 8080 to the container port 8080 and hit enter. Let's head back to our browser, open a new tab, and we should be able to access our service by hitting http://localhost port 8080/API/v1/info. And we have our host name, which is Python app. This is actually the pod name. Let's go back, and if you see, the pod name is Python app, ends with C7FVC, and the time. And we can also access our other endpoint, which is health. Let's replace it with HEALTHZ and enter. The status is up. Right now, our service is internal, which is good for testing. To make it accessible externally, we will use Traefik Gateway API. So let's head back to our browser, open a new tab, and type Gateway API, and open the Kubernetes official Gateway API documentation. The Gateway API is not installed by default in any Kubernetes distribution. You must apply the standard CRDs first. Let us click on Guides and choose Install a Gateway Controller. If we scroll down, we have a custom definition file. Let's copy and head back to our cluster and apply. So it has deployed a couple of custom resource definitions. We can simply run kubectl get CRDs to verify, and we have these resources related to our Gateway API. Let's go ahead and install Traefik on our cluster. Let's head back to our browser and search Traefik Gateway. Traefik is a modern cloud-native ingress controller that supports Gateway API and simplifies routing. We will define the HTTP route that routes traffic to our service, so we can access the Flask API externally through a domain or a load balancer. Let us click on Get Started and go to Quick Start, select Kubernetes, and we're going to use Helm to deploy Traefik on our cluster. Let's head back to our cluster. We currently don't have Helm installed. We need to install Helm. Open a new tab and search Helm install. And we'll go to Helm's official documentation. And if we scroll down, we have a simple script which we can run to install Helm for. Let's quickly run that. And run gethelm.sh. So it is downloading the package. Let me enter the password, and it has installed Helm 4. We can verify using Helm version command, and we have Helm 4.0.4. Let us add the Traefik Helm repo using the Helm repo add command. Let's copy and run. The Traefik repo has been added. Let us run Helm repo update. Once done, we are going to install the Traefik using the following Helm install command. So we're going to run Helm install. I will call my release Traefik. Then we're going to deploy it in the Traefik namespace. Since the namespace doesn't exist, we will pass --create -namespace command, which will create the namespace. Since we already deployed the Gateway API CRDs, we're gonna pass skip CRDs, and we will set the service type to node port so it can receive traffic from client port mappings, which we created earlier. We're going to set our node port to 30080 and hit enter. The traffic is deployed. We can run kubectl get pods -n traffic -w. The pod is in running state. Once the traffic is installed, we need to make sure traffic has recognized the gateway API. We can do that by running kubectl get gateway class to check if the gateway class is admitted. We can see in the controller section, it says traffic.io/gateway controller, which means it is accepted and we are ready to apply our gateway and create HTTP route. Let's head back to our VS Code and create a new manifest called http route.yaml. If we head back to the Gateway API official documentation, on the left-hand side, click on HTTP routing. And if we scroll down, we can copy the following manifest and modify to expose our application using the HTTP route. The kind is HTTP route. Let us go ahead and change the name. I will call this Python app route. And we're not going to specify the namespace since it is in the default namespace. In the parent ref, we're going to change the name to Traefik Gateway. And we need to add the namespace, which is traffic. Ensure it is pointing to the traffic namespace. And in the host name, let us go ahead and change it to Python app.test.com. And let us change the path /login to / then the name of our service, which is Python app service, and the port is 8080. So Python app service. That's all. Let's go ahead and save, and we can apply this using kubectl create -f http route.yaml. Let's hit enter, and it is created the HTTP route. We can run kubectl get http route and see we have an HTTP route. And we can also describe the route, kubectl describe HTTP route, then the name. And if you see, the reason is not allowed by the listener. This is the non-issue. Let us go ahead and quickly fix it. If we run kubectl get gateway in the namespace traffic, we have a traffic gateway. Let's edit the traffic gateway. We'll do kubectl edit gateway, then the name of the gateway followed by the namespace. We need to change the allow route namespace from same to all. Let's make this all. Let's save and exit, and let us go ahead and get the HTTP route again. kubectl get HTTP route, and let's delete and recreate kubectl delete -f HTTP route. So it is deleted. Let us go ahead and run kubectl create -f HTTP route. And let's describe the route again. And we can see the status is true and it is accepted. So now we should be able to access our application using HTTP route. Now, if we try to access our hostname, which we defined in the HTTP route, python-app.test.com, it will not work because it does not have any DNS record. So let's go ahead and update our /etc/host file. Let's do sudo vim /etc/host file, and let us go ahead and update our backend to map to our local host. I will say 127.0.0.1 followed by Python app helm.test.com. Let's save and exit. Let's go back to our browser and open a new tab and type http://pythonapp.test.com/API/v1/info. So we are able to access our backend using our HTTP route. So it says the host name and the time. If we head back and run kubectl get pods, and it ends with C7FV6, and we have C7FV6, and we also have the time. So we have successfully created an HTTP route, and we are able to access our application. As project grows, managing multiple YAML files become complex. That's where Helm comes in. Helm is the package manager for Kubernetes. We will create a Helm chart for our Python app, which templatizes our deployment, service, and HTTP route files. Let us go ahead and create a directory to store our Helm charts. Let's run mkdir and create a directory called Helm charts. Once done, let's navigate into the directory. And let us use the helm create command to create a directory structure along with the common files and directories used in a chart. The command is helm create and the name of your application. Let us create Python-app. So it has created a helm chart directory along with the files and the directories used in the chart. We can take a look. Let us say tree Python app. It has created a chart.yaml, then it has different templates like deployment, service, ingress, etc. Then we have a values.yaml file. We need to customize this default Helm chart so that we can deploy our Python API application on Kubernetes. Let's head back to the VS Code. Let's close all these manifest files. We have two directories in Infra-repo. One for Helm charts, other one is KTS manifest. Let us take a look at the Helm chart. The first thing is you have a charts directory. Then you have a template directory, which has all the manifest like deployment.yaml, then HTTP route, service.yaml, etc. Next, we have a chart.yaml file, which has the API version v2, the name, which we call Python app, the description, and other information. This is the values.yaml file. With Helm, deploying update is super straightforward. We just need to update this file and we can run a Helm upgrade. This would ensure that the changes are deployed into the cluster. So the first thing, let us go ahead and clean up the unnecessary files. We need a deployment.yaml file. We are not using HPA. Let's go ahead and delete HPA. Then we'll use HTTP route. We don't need ingress.yaml. We can delete ingress. Rest is fine. Let us go ahead and update the values.yaml file first. So we're going to have the replica, which is 1. Then the repository, we need to change it to our image, which is mkbn/Python app. Then the tag, we are using the tag v1. So let's update the tag to v1. And if we scroll down, we are not going to touch the service account. That is fine. The service type, it's okay because it's a cluster IP service. We're going to change the port, which is 8080. Then we're going to define a target port, which is going to be 5000. This, if you remember in the Python app, we have defined our application port, which is on 5000. Hence, we are setting our target port to 5000. And ingress is set to false. So the next thing is we need to enable HTTP route. So let us go ahead and set the enable flag to true. Then in the annotations, we're going to set the parent reference. The name is Traefik Gateway. So let's open the manifest file to the right so it would become easier for us to update the file. So if we take a look at the parent ref, we have the Traefik Gateway. Let's copy and paste. Then the section name, then we need to define the namespace. So we can just copy and paste the namespace, which is Traefik. Remove this, it's not required. Then the host name, we will set it to pythonapp.test.com. Let us close it in quotes. Next, we have to match the rules. The path is prefix, then the value is slash. That is fine. Then we need to add the backend ref. Let us copy this and paste. So we have the backend ref, which is pointing to our name, Python app, then the port 8080. So that's all the changes. Okay, one more thing. We have to specify the liveness and the readiness probe. In our case, it is /API/v1/health. And let's set the same for our readiness probe. And let's scroll down. And that's all the changes we need to make in the values.yaml. Let's save it. And if we take a look at the deployment.yaml file, not this one, let us minimize the manifest, go to templates. Let us open the deployment.yaml and the service.yaml file. And if we take a look at the container port, it is pointing to the port here. The port and the target port is same. So we need to change the service to target port so that it would be 5000, not 8080. So let's head back to our terminal, and we currently have all the deployments, HTTP route and service. Let's go ahead and delete them. So we have deleted the deployment, then the HTTP route and the service. If you run kubectl get all again, we should not have any resources. That is good. Now let us go ahead and install our application using Helm chart, which we created. The command is helm install, and the name of your release, I would call Python app, then your chart directory, in our case Python app. Let's hit enter. And our application is deployed. We can run kubectl get pods to check our pod status, which is running. We can also take a look at the service, and the service is called Python app. Then finally, let us take a look at the HTTP route, and we have a route called Python app. We can also describe the HTTP route to check if it is accepting the traffic from our service. We can do that kubectl describe, then HTTP route, then the name HTTP Python app. In this case, let's go ahead and describe, and it is accepting the traffic. So if you head back to our browser, and let me close this, open a new tab, and we should be able to access our application over python-app.test.com/API/v1/info, and we are able to access our API. And let us also test the health, and the status is up. And we have successfully deployed our Python application using Helm chart. So let us go ahead and push all our manifest files into a GitHub repo before we can proceed with our next step. So let's head back. I will open a terminal, and if we go to the infra-repo, and let's do git status. So we have created two new directories, Helm charts and the Kubernetes manifest. Let's run git add dot. Let's run git status again, and we have the following files ready to be committed. Let's do git commit -am. I would say added Kubernetes manifest and Helm charts. Enter. Let's go ahead and do a git push origin main. And if we head back to our GitHub Infra-repo, and we have our Helm charts and the Kubernetes manifest. Next, let's explore Argo CD, a GitOps tool for continuous delivery. In a new tab, let us search Argo CD and open the Argo CD official documentation site. Instead of manually applying YAML files or Helm charts, Argo CD can automatically sync our Kubernetes workloads based on what's defined in our Git repository. This is what we're going to do in this section. We are going to install Argo CD on our cluster using Helm and expose its UI using Traefik Ingress. Once we're done, you will have an understanding of how to use Traefik HTTP route and Ingress. Then we will create an Argo application to deploy our Python Flask API from our custom Helm charts. Let's go ahead and install Argo CD. Let us add the Argo CD Helm repo using the Helm repo add command and run Helm repo update Argo. And we're going to install Argo CD using Helm install and call our release as Argo CD, then create a namespace called Argo CD and set our server to insecure so that we can access our Argo CD using HTTP. Let's hit enter. The Argo CD is deployed in our cluster. In another tab, let us run kubectl get pods -n Argo CD. Looks like all our pods in the running state now. And we can check the service by running kubectl get svc -n Argo CD, the namespace. And we have the Argo server, which we can use to access our application. Let us expose our Argo CD service using Ingress. Let's head back to our browser. In our Kubernetes official documentation, let's search for Ingress and open the first link. Let's scroll down and we are looking for a manifest with the hostname. Let us copy this and let us create a new directory called Argo CD. Let's navigate into Argo CD and we'll create a new manifest called argo-ingress.yaml. Let's go ahead and update the name. I will call this Argo CD server Ingress, then the namespace, which is Argo CD. Let us change the host and we can set it to anything. I would just set argocd.test.com. Then the prefix, we're going to set it to /. Then in the backend, the service name is Argo CD server. Let's update. And the port number is 18. We need to add the following annotation, which is traefik.ingress set to web. So that's all the changes we need to make, and let's save and exit. So we have argo-ingress.yaml. Let's go ahead and create it using kubectl create -f argo-ingress.yaml. Let's run kubectl get ingress -n Argo CD, and we have Argo CD server Ingress, and it is pointing to the host argocd.test.com. So let's copy this and let's update our host file. Let's create another entry 127.0.0.1, then argocd.test.com. Let's save and exit. And let's head back to our browser, open a new tab and search Argo http://argocd.test.com. And this is our Argo UI. The default username is admin, and let us get the password using the following command. And this is the password. Let's copy and paste. Let's click on sign in. So we have logged into our Argo CD UI. Let us change our Argo CD UI password before we can create an application. Click on user info and update password. Let's paste our current password and create a new one and click on save new password. And our password has been successfully updated. we can log out and we can log back in with our new password. I'm able to log into my Argo CD UI using the new password. Now, let us go ahead and create an application to deploy the Python Flask API from our custom Helm chart. The first thing we need to do is connect our GitHub repo. Let us click on Settings and click on Repositories and Connect Repo. We're going to choose the connection method HTTP or HTTPS, and the type is Git in our case. The name is optional and we can select the project as default. And for the repository URL, let's head back to our GitHub and copy the HTTPS link and paste. Since it is a public repository, you don't need a username or a password, and we don't need to make any other changes. Let's click on Connect. And we have a successful connection status. Let us create an application. You can click on New App or Create Application. And we're going to call our application Python App. And the project is default. We will change the sync policy from manual to automatic so that whenever we make changes in our repo, Argo CD would automatically pull those changes and deploy it into our Kubernetes cluster. In the sync option, let us check auto create namespace and scroll down. In the source section, let us change the repository URL to our GitHub repo, which we configured. And in the revision, we have only a single branch, but in production, you might have multiple branches. So it is recommended to specify the branch. In our case, it is main. And for the path, let us head back to our GitHub repo, and our Helm chart is inside helm-chart/Python app. So this is the path. Let us copy and set the path. In the destination, we have a single Kubernetes cluster. Let us select that. And the namespace, our application will be deployed in a default namespace. So I will choose default. And that's all. We don't need to make any other changes. Before we can click on create, let's head back. I just removed our previous installation to ensure that our cluster is clean. If we run kubectl get pods, we currently don't have any pods. We can also run kubectl get pods-a. Yeah, you might see related to Argo CD and kubesystem, nothing related to our Python application. Let us go ahead and do a kubectl get pods watch, then come back to our Argo CD, click on create application. So let's open the Python app. So it's already healthy, synced, and everything looks okay. So it has created a service called Python app. It has a service account. It has a deployment called Python app, and it has created an HTTP route. And if we head back to our terminal, we have our Python app running, which is created a second ago. And we can do kubectl get svc. So we have our Python app service, and we can run kubectl get http route, and we have our route also. Let us try to access the route. Let's head back to a browser, open a new tab, and type http:// then API/v1/info, and we have our host name and time. As always, we can just verify the last 5 digits, which is L8KBR, and the pod name is L8KBR. So we have successfully deployed our application using Helm chart through Argo CD. Now, if we make any changes to our Helm charts, Argo CD would automatically pull those changes and deploy those changes into our Kubernetes cluster. But If we make any changes to our application, those changes will not reflect because the image which we built currently will not have those new feature. What I mean is, if I try to add a new field called environment, and we'll call it dev, and save these changes, and if I redeploy using our Argo CD, these changes will not be reflected because we need to rebuild our Docker image with these changes, then push our Docker image to our DockerHub, and once done, we need to update the image tag, and once the image tag is updated in our Helm chart values.yaml file, and those changes will be pulled by our Argo CD and deployed to our cluster. Creating a new Docker image with our changes, pushing it to DockerHub, then updating our Helm charts values.yaml files with the latest tag is not recommended. So let us go ahead and automate the entire pipeline using GitHub Actions. GitHub Actions help us define automated workflows directly in our repository. In our Python app repo, let us go ahead and create a directory called .github/workflows. Let's minimize the infra-repo and select the Python app, click on new directory, and we'll create .github/workflows. And inside the workflows, let us create a YAML file called cicd.yaml. This is where we are going to define our CI/CD pipeline, which our GitHub action will use and execute. Let me walk you through the CI/CD pipeline. So we have a name and we're calling it CI/CD pipeline. Then this pipeline will be triggered when there are changes pushed to the branch main. Then we have a single job, which is build and push, which runs on Ubuntu latest. And if we take a look at the steps, it checks out our repository, then log into our DockerHub and build the image and push it to our DockerHub. So we are using the GitHub SHA to create the unique tag for every build. So let's save this. And before we can push it, we need to create the Docker username and Docker password secrets in our GitHub repo. Let's head back to our GitHub. Let's navigate to our application repo, which is Python app, and click on settings. On the left hand side, you have secrets and variables. Let's expand it and click on actions. We're going to create two secrets, one for our username and other one for our password. Let's click on new repository secret and name our secret Docker username. And in my case, it is mkbn, and I will click on add secret. We'll create another secret and it is Docker password. Let me quickly paste the password and click on add secret. Once done, we can go ahead and push these changes to our repo. Let us head to Python app, and if we do git status, we have modified the app.py. We have added a new field, environment dev. Then we have created new directory called workflows and created a cicd.yaml file. So let us go ahead and do git add dot. Let's do a git status again to check the changes can be committed. Let us do a git commit -am. Then I would say added cicd.yaml file. And let us go ahead and do a git push. Let's head back, and if we go to our Python app repository and we have a new action, let us go to actions. It is running the stage, which is build and push. Let's take a look at the different stages. It is build and push Docker image. It is building the Docker image, logs into our DockerHub, then push our image to our DockerHub. If we head back to our DockerHub repository and we have a new image pushed a minute ago, let us open this. And if we take a look at the tags, we have the tag which is the commit hash. Let us go ahead and modify our CI/CD pipeline so that we can shorten our tag, which will be easy for us to update in our values.yaml file. Let's head back. Let me close this. Let us add an output section so that the next stage can access our short commit SHA. So under runs on, let us add an output section. We're going to create a new step which will get the short SHA. Let us, after checking out our code, we will add a stage or a step which gets the short SHA from the output. Next, we need to update our image tag. Let me go ahead and update this. So we will get the image SHA from the short output and we will tag our image. So these are the changes. Let's save and push this to GitHub. So we have pushed our changes. Let's head back to our GitHub. And if we scroll up and click on actions, we have a new build triggered. And our pipeline is running. Okay. And the job is completed successfully. Let's head back to our DockerHub and let us go to Python app. And we have a new tag, which is created less than a minute ago. This is much easier to update and read. Finally, let us go ahead and define a new stage to automatically update our image tag in our Helm manifest. In our CI/CD.yaml file, let us create a new stage called update manifest, which needs a build and push stage, which is our previous stage. We are going to check out our infrastructure repo. We have created two repos, one for our application code, which is called Python app. The other one is called Infra-repo, which holds all our Helm charts and Kubernetes manifest files. The repository is the username / the repo name. In my case, my username is mkbntech and the repo name is Infra-repo. We need to grant access to our GitHub Actions so that it can commit changes to our infra-repo. We will create infra-repo token to grant those permissions. We have a new step which updates the image tag in Helm values. You need to pass the path. In my case, it is Helm charts, Python app, then the values.yaml, and we are using the YQ to update the image tag. And finally, it commits and push the changes to infra-repo. Let's go ahead and create the infra-repo token. Let's head back. I'll go to my GitHub and click on your username. Go to settings and scroll down. Click on developer settings. We need to create a personal access token and we'll choose token classic. And let us create a new token classic. So I will call this CI/CD pipeline token. Then let us select the repo, so which grants our access token the repo level access. Let's click on generate token. Go ahead and save this safe somewhere, because once you close this page, you will not be able to get this back. So let me paste it somewhere. And now let's go back to our repositories. Python app repo. Click on settings. And let's go to secrets and variables, actions, and let us create a new repository secret called infra-repo token and paste the token which we generated. and click on add secret. So we have 3 secrets: Docker password, Docker username, and infra-repo token. And we need to make one more change. That is, we need to update our values.yaml file with our current Docker tag. Okay, let us go ahead and copy the current tag, which is this, and let us change tag v1 to, let us go ahead and push these changes. Let's go to the infra repo, and if we do git status, and we have modified the values.yaml file, and we have argo ingress.yaml. So let's go ahead and do a git add and do a git status again. And we have 3 files to be committed. Let's do a git commit, and we will say updated image tag, enter. And let's do a git push. Before that, before I push, I just want to show you something. If we head back to our Argo CD, let me click on application. It is currently synced. And if we currently open, we saw we don't have an endpoint called env, right? Because that does not exist when we deployed our image. So let's go ahead and do a git push now and see how Argo CD automatically pulls those changes and deploys that into our cluster. Let's do a kubectl git pods here, and let's keep a watch. And these changes are pushed to our repository. Let's verify. Let's go back to mkb and tech repositories, infra, and we should have a new commit, and we have Argo CD. And if we go to our values.yaml file, we should have a new tag which we updated. That is good. And let's head back to our app. So it currently still points to our previous commit, which is added Kubernetes manifest and Helm chart. Let us give it a minute for our Argo to sync our changes automatically. So it is synced, as we can see, and it is deploying a new pod. So this is the old pod, and it is creating a new pod. If we go back to our UI, we can see it is creating a new pod. I mean, it is already in running state. And if we head back and let us open a new tab and try to access http://python app test.com API/v1/info and hit enter. So we see we have a new info, which is environment is equal to dev. This is something which we added. So we have automated the entire process of building the image, pushing the image to DockerHub, and automatically Argo CD syncing those changes and deploying those changes into our cluster. So we need to test one last thing, that is updating the image tag automatically, right? We already made our changes in the cicd.yaml file. So let's go ahead and push these changes. Let us navigate to Python app and do a git status. So we have cicd.yaml updated. We can also do git diff command, which will show you what changes we have made. These are the new changes. We can hit Q. Let's do a git add and do a git commit. Added image update stage. Enter. Let's do a git push. Now we'll see our image will be automatically built, and the new image which is tagged will be pushed to our DockerHub. That image tag will be updated automatically in our infra-repo. Argo CD will pull those changes automatically and deploy it into our cluster. So it is building a new image. We can see there is a new stage called update manifest, which is completed successfully. Then if we head back to our DockerHub, let's click on Python app, and we have a new tag which is 01EA, right? This is the new tag. Previously, if you can see, we have 452. So let's head back to our repository again. Let me click on mkbn tech and quickly go to the infra-repo. And we have a commit from our GitHub Actions, which says deployed image tag 0190. If you go inside the Python app and take a look at the values.yaml file, so our tag is changed 01E9B3. And let's go to our Argo CD, and Argo CD also have the same information, which is the commit deploying image tag 01EA9B3. And we have a new pod created 11 seconds ago. So that is fantastic. So let's recap everything we did in this end-to-end journey. First, we built a simple Python Flask API application. Then we containerized it using Docker, then deployed it to our Kubernetes cluster. We exposed it using Traefik Gateway API. Then we created our custom Helm charts and enabled GitOps using Argo CD. And we automated the entire process using GitHub Actions. Now you know how a modern DevOps workflow connects from code to container to cluster to continuous deployment. If you found this helpful, don't forget to like, subscribe, and share it with other DevOps learners. Thanks for watching. I will see you in the next one.